today we are going to start a new topic, that is intermediate value theorem on continuous polynomials. But before understanding this intermediate value theorem, you should understand the general basics of a graph. See, like we have discussed the making of a graph in previous lectures also. Like if we have been given out it's a function like fx is equal to y is equal to x minus 1 x minus 3, then find graphically the value of f minus 2 f2 f4. If we have to do it without graphically, we know that we directly substitute the values and will substitute over here as minus 2, then f2 and then 4. We can get the values, but we have been told first we have to draw a graph. Clearly, this is a parabola. Parabola meets the x-axis at point 1 and point 3. By substituting y is equal to 0, we got x is equal to 1 and 3. That means this is a graph. This is 1 point, this is second 2, this is 3. See, our parabola is passing through these points. As coefficient of x square is positive, we make a graph like this way. It is a general graph. This is a graph. Now, if we have been told that find out the value of f of minus 2, we know that the f of minus 2 will be what? F of minus 2 lies on the left side of 1. So this is a parabola. F minus 2 will come out to be positive, and that 2 equal to calculate करने का way out क्या है? That is same. हम क्या करेंगे? We'll substitute. It is f minus 2 is equal to minus 2 minus 1 minus 2 minus 3, and it comes out to be minus 3 into it comes out to be minus 5, and it comes out to be it is minus 2 minus 1 minus 2 minus 3, we got minus 3 minus 5, it is 15. So 15, obviously it will be somewhere here, it is f minus 2, it will go somewhere here as this is equal to 15 value. This point will be minus 2 comma 15. Similarly, we have to find out the value of this is 15 f2. So f2 lies between 1 and 3. Whatever values of x will take between 1 and 3, so that values will come out to be negative 1. Clearly 2 lies over here, so f2 will be here. It is 2 comma, this point is 2 comma f of 2. That means this is point 2. Then to get these value f of 2, we substitute over here, we got it f2. f2 is equal to 1 into minus 1. This is 2 minus 1, 2 minus 3 is minus 1. We got it minus 1. So this value is, we can write down 2 comma minus 1. Similarly, we can find out f4. f4 is on the right side of 3. Clearly it comes out to be positive values. Positive values, it is f4 positive. But how we'll get it? f4 ki value, we can calculate it. It is 4 minus 1 into 4 minus 3, we get as 3. So it is approximate here, it will meet the parabola. Wherever it is meet, we will say this is a meet, it will meet, this point will be, it comes out to be your 4 comma 3. This is a way out. So I have taken up a quadratic equation. Now I can take a case of your cubic equation also. See another cubic example. I take one cubic example as fx is equal to it is x plus 2, it is 1 minus x, it is x minus 3. Yeah, I will say we just change it over here. I take it x minus 4 say. Now first of all, before making a curve, we should make sure that the coefficient of x should be positive. So first of all, what I'll do it, I'll make this curve as a positive one. It is x plus 2. I'll take negative common over here. The curve will change into x minus 1, x minus 4. Now we'll see where this fx we take as y, where this curve will meet the x-axis. This curve will meet the x-axis at the points x is equal to minus 2, 1 and 4. Or we can say the roots of this equation fx is equal to 0 is, the roots of the equation fx is equal to 0 are minus 2, 1 and 4. Now we have to represent this thing by graph. Similar question, this is fx is equal to this one. You have been given draw graph and find. We take it few example like this. It is minus 3. Then we take it f of 0, and we have been told find out f, it comes out to be 5 also. F5 suppose. These are the things we have to calculate it. So what we'll do it, first of all we'll draw a curve. Now these are the points on, say this is the points on the x-axis. I represented minus 2, 1, 4. See carefully, now here the coefficient of highest term is negative. So in every graph I am going to start from here, but if coefficient of x is negative, I'll start it from downward like this way. The graph will be like this way. Now I'll just check it out the points where this these values f of minus 3, clearly f of minus 3. Where it will be f of minus 3? F of minus 3 lies on the left side of minus 2. Clearly f minus 3 will come out to be, it comes out to be positive. F of minus 3 is here, and here curve is above the x-axis. So f of minus 3 is equal to positive. Anyhow, if we calculate it, we'll get it what? It is minus 1 over here. We'll get it over here. It is 1 into minus 3, we'll get 4. And we'll get it minus 3 minus 4 minus 7. And the rightful value we got it, it is 28. So f of minus 3 is equal to 28. Obviously this will come up above the x-axis. Now we suppose calculated f0. For f0 we'll substitute over here. It is 0, this is 2. Here we get it, it is 1 minus 0, 1 minus 0, and here it is what? It is 0 minus 4 minus 4. We got it what? Minus 8. Now clearly f0 lies over here in between. So f0 comes out to be what? Negative. Even before calculating from graph we can check it out, f5 is positive or negative. f5 is below the x-axis, so f5 is also comes out to be negative 1. Anyhow, we can calculate the exact value of f5 by substituting 5 in this equation. We'll get it what? 5 plus 2, it comes out to be 7. And 1 minus 5, 5 minus 4. This is 7 into minus 4 into 1. We'll get it minus 8, 28 negative. Once again, I'll explain this example and try to understand clearly. See, first of all, before drawing a graph of a polynomial function, we make sure coefficient of a highest term should be positive. So I just make it positive by taking negative sign common from here. Now this is a curve. Now where the points where this curve meet x-axis, or we can say roots of fx is equal to 0 are minus 2, 1 and 4. I represent those points, I plot those points on the x-axis. Now clearly from without finding out, just looking upon the graph, I can check it out. F minus 3 is positive or negative. F minus 3 lies on the left side of minus 2. So F minus 3 will be positive. F minus 3 we can calculate it. Minus 3 substitute over here, we got 28. Similarly, F0 clearly it looks like from the graph it comes out to be negative. Negative we can find out, it comes out to be minus 8. And finally f of 5. F of 5 is again below the x-axis. So we just can say it is the value of f5 will be negative. We can calculate it putting 5 over here. We got it minus 28. See, I have done this general graphs before doing this intermediate value theorem, because you should have concepts very much clear in your mind when we are doing this theorem. Now, the topic name is intermediate value theorem on continuous polynomials. Means, although we are doing the topic quadratic equation, but this theorem is applicable on quadratic equation, on cubic equations, by quadratic and other polynomials also. So most of the questions we are going to get in competition, it will be on of quadratics only, but this theorem is applicable on all polynomials. The important points, the points of this polynomial, this theorem are: first point is, let fx be a polynomial. Let fx be a polynomial of real variable k, and a comma b belongs to R, and a comma b, what are a and b? We have taken any two real numbers, one is a, another is b. So we have taken two different, we can say a less than b, such that fa fb is less than 0. fa fb is less than 0. It means, see here, it should be clearly in your mind, here a and b are not the roots of function, it's not the roots of a polynomial. Here fx be a polynomial and a comma b are any two real numbers, right? Then such that fa fb less than 0, then fx is equal to 0 will have, at least one real root. Fx is equal to 0 will have at least one real root, or having odd number of roots, number of real roots, between a and b. Intermediate value theorem, it states if fx is any polynomial and this such that we have been a and b are any two real numbers, a less than b, and we have been given fa fb less than 0, then fx is equal to 0 will have at least one real root, or having odd number of real roots between a and b. इसका मतलब हुआ बेटा, one thing is clear, say we have been given out fa fb less than 0. Since fa fb less than 0, it clearly means either fa greater than 0 and f of b less than 0. If, because we know that the product of two quantities is negative, then one quantity will be positive and other quantity will be negative, or f of a will be less than 0 and f of b will be greater than 0. So we can take up any one example to represent this thing. Say I suppose it, say let f a greater than 0 and f of b less than 0. So this is a, say we take it any polynomial. So since we do not have, say say we do not have the roots of this polynomial. So we generalize, we find out, I just take it x is equal to a. This is point a comma 0 is on the x axis. This point is b comma 0 on the, this is on the x axis. This I have taken on the left side of a say y axis, I have taken this point on the right side. Elsewhere I can take both these points on the left hand side of y axis or right side of the y axis. Now we have been given, the only thing we have been given, product negative means I have taken this is positive. I suppose it this is a point, fa will be positive and fb I suppose it here. So I'll say fa suppose lie over here and fb lies over here. So obviously that this is a polynomial and it is a continuous curve. Then it one thing is sure, this curve must be like that. This curve must be like that. It clearly shows it has one real root, or we can say it will be at least once meet on the x-axis. I will say this equation, this polynomial clearly shows we have one real root. One real root. How one real root? As this curve meet the x-axis at only at one point. So this is one possibility. So this possibility exists only if product of two quantities is less than 0. Now to explain the another point, I have written over here, this equation will have at least one real root or having an odd number of real roots possible. Or we can say, I am drawing the another graph. Same way, I am taking f a is greater than 0 and f of b is less than 0. Means I just draw a graph and suppose this is a point, this is a comma 0 and I suppose this is a point, this is called a comma f of a. Suppose this is a point b, it is b, it is b comma 0, I suppose this is f. Now this way we can say fa into fb will be less than 0. Now one way curve can be, see curve at one point here, one point will here, they are going to meet. So they are going to meet in between, it can be like this 1, 2 and 3. Say it is definitely going to meet at this point and this point. In between it will either meet x-axis at one point or 3 point. Like here we can say there are 3 roots, alpha 1, alpha 2, alpha 3. And we can take up another example. Suppose it is, say I just draw another one. It comes out to be a comma 0 here and here b comma 0. Now the curve, it is fa is positive, fb is negative. I can do it this thing, curve may be like this 1, 2, 3, 4 and it meet over here. So we will find out it is alpha 1, alpha 2, this is alpha 3, this is alpha 4 and this point is alpha 5. So what I have written over here, मैंने यहाँ पे लिखा था, if we have been given, यदि हमें given होगा कि fa fb less than 0, it means either we have one root or we have 3 root or we have 5 root. That's why say this is a best example, I have taken it over here. Now the problem based on this graph will do little late. First of all, I am doing the second point. The second point is fx, let fx is equal to 0 be a polynomial where a and b belongs to real number. Same way I have taken it, a and b are any two real numbers, and clearly again a comma b are not the roots of this equation fx is equal to 0. Then then FA comma FB greater than 0, then FA into FB greater than 0, it implies that, see, fx is equal to 0 be a polynomial where a comma b belongs to R, then FA FB greater than 0, then fx is equal to 0 has either no root, or even number of roots, between A and B. Similar examples. See, we have been given out what? See, FA into FB greater than 0. So we take it, it is FA comma FA into FB greater than 0. We can conclude from here either FA greater than 0 and FB greater than 0, means either both these quantities will be positive or both these quantities will be negative. FA less than 0 and F of B less than 0. So we can conclude from here that either FA FB, if FA FB is greater than 0, we can conclude either FA positive, FB positive, or FA negative, FB negative. So we can take it any one case from here. Suppose we take it this one case over here. It is FA greater than 0, FB greater than 0. Similarly, like, see, now we just draw a graph over here. See, I suppose it A over here, A point is here, and I just suppose it B point is here. This comes out to be, I'll just draw again a graph over here. This is x-axis, this is y, this is A, this is B. This is A, this is B. Now, this is f of A. We have been given FA, FB. I have taken it both positive, means we have been given FA, FB are both positive. And at these 2 points, curve must pass, and it is a continuous. It is a, since polynomials are always a continuous function. So one case will be, it meet the curve like this way. So clearly indicates this curve do not meet the x-axis, means no real root. Now I take another case. Another case is FA greater than 0, FB greater than 0. So both these quantities are positive. Second graph is, this is A. This point is A comma 0. This point is B. This point is B. So now we draw a, see, at these 2 points, curve will definitely pass through these 2 points. That means curve may be either like this way, it goes like this way. It goes below the x-axis and then it come up. Come up means it meets the x-axis at 2 points, and we can say here it has 2 roots. It is alpha 1, say it is alpha 2. So if product of 2 quantities is positive, मतलब FA, FB 0, then we can say it has either 0 root or 2 roots, or we can similarly, this is A, this is B. It may be like this way, it goes below the x-axis, come up, below, and then it goes like this way. So it may have 1, 2, 3, 4. So it may has 4 real roots, So we conclude from here, what the conclusion is, if FA into FB less than 0, then we have odd number of roots. We have odd number of real roots. And if we have been given FA, FB greater than 0, then we can conclude from here is even number of roots, even number of real roots, or no roots, no real roots. Now this is the all theory of this intermediate value theorem. Now we'll start doing the questions based on this say intermediate theorem. These all questions are part of our booklet which has been provided to you. In case you didn't bring your this booklet with you at presently, so I am writing down the questions here also. Our first problem is value of A for which exactly one root of 5x square plus a plus 1x plus a is equal to 0 lies in the interval 1 less than x less than 3 is A option we have been given out A greater than 2. B option is minus 12 less than A less than 3. And C option is A greater than 0. And the D option is none of these. So here also no roots has been given to us. We have been given value of A for which exactly one root of this equation lies in the interval f1 and 3. We have been given one root lies in this interval 1 and 3. So what I'll do it, see, I'll find out first of all, say I suppose that fx is equal to 5x square plus a plus 1x plus a. I take this as a polynomial. Now I'll calculate f of 1 from here. F of 1 it is 5 into 1 plus a plus 1 into 1 plus a. We got it what it is 2a plus 6. Now we have been given another thing, it is f3. We can calculate f3. F3 is what? 5 into 9 plus a plus 1 into 3 plus a. 9 5 to 45 plus 3a plus 3 plus a. We got it 4a plus 48. So f1, f3. We calculate f1 and f3. Now we have been given what? Exactly one root. See, we have been given exactly one root. It means we are applying intermediate value theorem, which states, see, now we are using the reciprocal. We have been given that one root lies in between. It means, see, since one root lies between 1 and 3, we can conclude f1 into f3 must be less than 0, because 1 is odd. 1 is odd, it means we can conclude from here that f1 f3 is less than 0. That means f1 we have calculated, it is 2a plus 6 into 4a plus 48 less than 0. Now we can take it common, 2 into a plus 3 into 4 a plus 12 less than 0. Divide by 6, a plus 3 a plus 12 less than 0. And now similarly, as we have done in previous question also, we draw a what? Parabola. It is minus 12 over here, minus 3 over here. It is like this way. It is see, again we have to check it out here, because this answer has been given minus 12 and 3. So if should not have make any mistake over here, it is it is 5x square plus a plus 1. f1 will be equal to f1 plus a plus 1x plus a. It is true, here we are correct, it is 2a plus 6 But now we again check it out. If we should not have make any mistakes over here, it is x lies between 1 and 3. See how we have make a mistake over here. It is, sorry, it should be minus 3 over here. See, now we'll reach it over here. We draw a parabola. It is positive, negative, positive. And here we want this expression is negative, but when it will be negative? When a lies between minus 12 and minus 3. And the right option is B. So once again, you try to understand application of intermediate value theorem. Application, see, this is a question. Value of a for which exactly one root lies in the interval. We have been given one root. One root lies in the interval. I find out f of 1. I calculate f of 3. And f of 1 is this one, f of 3 is this one. Now using intermediate value theorem, that means if it has one root, I can conclude f1 into f3 less than 0. Then it is 2a plus 6, 4a plus 48 less than 0. Divide by, I take it 2 common here, 4 from here, a plus 3, a plus 12 less than 0. Now we draw the x-axis, minus 12, minus 3, and it is plus, minus, plus. A lies between minus 12 and 3. We can conclude from here that this expression will be negative when a will be minus 12 to minus 3. So right option is B part. Now, the next problem of our booklet is the question is if B greater than A, then equation x minus A, x minus B minus 1 is equal to 0 has. First option we have been given both roots in A comma B. B option is both roots in, it comes out to be both roots in minus infinity to A. C option is both roots in B to infinity, and the D option is one root in minus infinity to A, and other in B to infinity. See another example of intermediate value theorem. We have been given that B greater than A. See, if we put FB over here, we are not going to get a 0. Means A and B are not the roots of this equation. So we take a polynomial same way like we have done in the last question. Say let fx is equal to x minus A, x minus B minus 1. Now f of A we calculated, f of A is 0 minus 1 minus 1. F of B, it is 0 minus 1, it is minus 1. So we got the values FA and FB as minus 1, minus 1. Now we can say FA into FB. FA into FB is equal to 1. 1 means positive. FA is equal to FB positive. Since we have done in intermediate value theorem that FA, FB is equal to positive, it means the graph of our this function will be, it will be like this way. Say I can say A is over here. This is A over here, suppose B is over here. FB is somewhere positive. FA is positive. FB is what? FB is again positive. Sorry, I am doing a little mistake. FA is negative. So I just take it. FA is negative. FA is minus 1. FB is minus 1. Now FA FB is equal to positive. Then graph will be like this way. See, FA negative, FB negative. I can say the graph, since see we have been clearly mentioned out over here, this equation has roots. Clearly indicate this has real roots. We have been given the equation has roots, clearly indicate we have real roots. Real roots means this curve must be passing through 2 points. That means this curve will be something like this. From FA and FB, it in between it never cuts the x-axis. So we can say this is fx is equal to alpha is one root, f beta is another root. So these are the roots. Now what is the answer? Answer has been given out. Both roots in this one? No, both roots. कोई भी रूट नहीं लाई करता हमें a और b के बीच में. Both roots in minus infinity to no. Root alpha, it lies from minus infinity to a. Other root beta is lie between b to infinity. So right option is D part. See, once again you understand this thing. FA, FB is positive, and we can conclude from here FA, FB is negative. FA, FB is positive. So the curve will be like this way. It in between A and B, it do not cut the x-axis. So this is alpha, this is beta. So one root lies in minus infinity to A, one root lies between B to infinity. Some more problems on intermediate value theorem. Again, these all problems are part of our booklet which has been provided to you. The problem is if A less than B less than C less than D, then equation 3 x minus A x minus C plus 5 x minus B x minus D is equal to 0 has. The four options have been given out. A option is real and distinct roots. B option real and equal roots. Real and equal roots. C option purely imaginary roots. Purely imaginary roots. And D option is none of these. See, this is the equation. This is the equation, and there are four variables. There are four different constants A, C, B, D. The only thing about these constants we have been given out, that is A is less than B, less than C, less than D. So clearly no other condition have been given out. Four constants. Then what will do it? We'll try to do it same way. That is the question we are doing it using intermediate value theorem. We find out first of all it is f of A. F of A, say before f of A we suppose let fx is equal to 3 x minus A x minus C plus 5 x minus B x minus D. Now it is f of A. F of A is equal to 3 A minus A into A minus C plus 5 A minus D A minus B A minus D. We can conclude FA is equal to, this is 0 plus now 5. See, basically we are interested this f a b c d are positive or negative. So we just calculated a minus b. Since a is less than b, a less than b, I'll say it is negative. Now a minus d, again it will come out to be what? It is a minus d. This again will come out to be negative. Negative into negative, it will come out to be positive. Now we are calculating f of b. F of b, it is 3. B minus a, b minus c plus 5. B minus b, 0 into b minus d. This term will be 0. Now we just check it out. B minus a is positive or negative. This will be positive as a is less than b. Now b minus c will be negative. That means fb is negative. We find out f of c. F of c will come out to be c, again 3. C minus a into 0 plus 5 c minus b into c minus b. This becomes 0, f of c. This is c minus b. C minus b will be what? It will be positive. And c minus d, it will come out to be again negative. So c minus b, it comes out to be positive, and c minus d is negative. Fc overall will come out to be negative. Then finally we find out f of d. It is f of d. F of d, it is 3 d minus a into d minus c plus this 5 d minus b into 0. This is d minus a is positive into positive. We got it positive. So we underline it. It is fa is positive, fb is negative, fc is negative, fd is negative. Fd is positive. Since nothing has been given out, what we are going to do it over here. Now we are going to plot a graph. See, I just take it. It is, this is x-axis, this is y-axis. See, the only condition we have been given out, that is a less than b, less than c, less than d. So I take these four numbers in a order. I take it, this is a, this is b, this is d, this is d. See, I have taken 2 over here and 2 over here. It does not mean we always have to take it like this way. See, we can take these all four points on the right hand side or on the left hand side. See, now we have to see, we have to calculate the value. Fa is somehow some positive. Fa is some positive, so I take it that positive value, that value will come out to be here. Then we plotted Fb. Fb is negative. We suppose it will be down the x-axis, it may be over here. Fc, it may be down, it may be up to here or up to here, it hardly makes any difference. I take it up to here. It is Fc is also negative, and finally Fd comes out to be positive. So we can say one thing, that a curve passes through these all 4 points. This is 1 point, second point, third point, fourth point. That means if we join these 4 points, the curve we form it is, see, one thing is sure, this is a quadratic function. This is a quadratic function, so we are definitely going to get a parabola. Say, on these basis we can say one thing about it, that this curve passes through 2 points on the x-axis. This point, cut the x-axis at 2 points. One point will be between a and b, another point will be c and d. This shows our roots are what? It has this one root alpha, this is another root beta. So we can conclude roots are real and distinct. It has 2 roots and both these roots are real and distinct. Again, a difficult question for you, but I think a concept, if you thoroughly know the concept and use it properly, I think it question really becomes easy. See, once again I am explaining this question. This equation has been given out and there are 4 constants. The only thing about this constant we have been given out, that a less than b, less than c, less than d. It means See, I am going to use intermediate value theorem over here. I have taken fx, this one. This one I have taken is as fx. Now I will calculate it f of a. It will be 0 over here and it will be fa will come out to be positive. Then I take it f of b. F of b, I substitute over here b minus c, b minus c. See, this term will become 0. b minus a positive, b minus c negative. Ultimate f of b will come out to be negative. So fc, we just check it out, 3, c minus a into 0, then c minus c 0, c minus b, c minus d. C is what? Greater than b, so positive, c minus d, c less than d, so negative. So ultimate positive into negative, we got it negative. Then we calculate f of d. F of d is 3, d minus a, d minus c, it is d minus b into 0. D is the largest of all, it means d minus a positive and d minus c positive, that means fd is positive. So I have taken the general point, general things. General means I have taken FA positive, means any positive, the value will come up the x-axis. FB will be down the x-axis. FC, this is, we can say this is f of A. This point is f of B. This point is f of C. This point is, it is f of D. At all these 4 points, our curve passes. It means joining all these 3. Now we got a parabola, clearly mentioned out, this is one root. If you ask me the location of the roots, I will say that root will lie between A and B over here, and here beta will lie between C and D. So the another problems based on this intermediate value theorem. The problem of our booklet is, it is given that ax square plus bx plus c is equal to 0 has no real roots, and a plus b plus c less than 0, then 4 options we have been given out. A option is c is equal to 0, B option is c greater than 0, C option is, it is c less than 0, and the D option is c less than equal to 0. Now whenever it comes out to be no real root, the idea should strike our mind that this curve, this quadratic, is not going to meet at x-axis. Since we know one thing, see, we have done in a graph, if fx touches, if this curve y is equal to ax square plus bx plus c touches this x-axis, it means it has two equal roots. It means two equal roots. One thing we know about it. And similarly, if this curve cut the x-axis at 2 points, it has two distinct roots. And in both these cases, a greater than 0. And in case curve do not means curve do not meet the x-axis, means it has no real root. So this is the case. We can say, we can presume this curve, general graph of a curve will be like this one, since it has no real root. So we conclude from here that is, see, let fx, we suppose it is ax square plus bx plus c. Now one term we have been given out, that is a plus b plus c. So we can see from here, if we substitute x is equal to 1, we get a plus b plus c, or f of 1, a plus b plus c. F of 1 is a plus b plus c, and we have been given what? This is a plus b plus c less than 0, which means we can say f1 is also less than 0. See, we have to calculate the value of c. We have to tell out of a c. Another thing we look carefully in this function. If we put x is equal to 0, we take f0. F0 will be a into 0 plus b into 0 plus c. It is f0 will come out to be c. So, by using this intermediate value theorem once again, we can say one thing. It has since this function has no real root, means curve do not meet the x-axis, I can say f0 into f1 will be less than 0 as it comes out to be f1 is negative, so f0 should be negative. As f1 is negative, so f0 should be less than 0. That means we can say f0 is negative. So f0 less than 0, say f0 less than 0. f0 less than 0 will say c is less than 0. And the right option is C part. Once again, see in this question, see we do not have been given out how we get it a plus b plus c. We have to think how to use this condition, and we should know it. If we take f1, we'll get it a plus b plus c. To get c, we get f0. So I find out this equation do not have real roots. It means this curve, this case will be either like this way. If we ask about the graph, say it will be either like this way. It is either क्या आ जाएगा? It is either above the x-axis, or we can say it is below the x-axis. Since it has not been given out कि a positive है कि negative है. So curve is, so the only thing we can say about it, it is f1 is negative, so f0 should be negative. f0 negative means c less than 0. Next problem based on this intermediate value theorem. Now we can use intermediate value theorem. This is a little different from intermediate value theorem question. Say intermediate value theorem. The problem is it has a use of inequations we have done before. It is the problem is if a belongs to z, z means our integers, and equation x minus a, x minus 10 plus 1 is equal to 0 has integral roots, means its roots will be integral, means 1 2 3 or minus 1 minus 2 minus 3 like this way. It has integral roots. Then a are a option it is 10 comma 8, b option is 12 comma 10, c option is 12 comma 8, and the d option is none of these. See, what will do it? We'll simplify this quadratic equation. X square minus a plus 10x plus 10a plus 1 is equal to 0. See, we have been given this equation has integral roots. So we also can say roots are real. Since roots are real, that means again using the properties of a roots, that is discriminant will be greater than or equal to 0. A plus 10 the whole square minus 4 into 10a plus 1 greater than or equal to 0. A square plus 100 plus 20a minus 40a minus 4 greater than or equal to 0. A square plus 100 minus 20a minus 4 greater than 0. It will become a minus 10 the whole square minus 2 square is greater than 0. Now we can say what it is. a square minus b square, a minus 10 minus 2, a minus 10 plus 2, it is greater than equal to 0. Now we can say a minus 12 into a minus 8 greater than equal to 0. Same, a graph of a parabola, it comes out to be this is 8, we can say this is 12. Coefficient of a square is positive, so parabola will be like this way. Now here we can say the value of a will be less than 8 and a greater than 12. The value of a which satisfies it, a less than equal to 8, a greater than equal to 12. So looking upon the given options, we can say a less than equal to a is equal to 8 will be one value, a is equal to 12 will be another value. That is, the right option is C. The next problem of our booklet is again, see this question carefully, read it carefully and just see the steps how we should solve it. See again, a very best use of intermediate value theorem. See, I just want to make sure if you get a question like this way, you should not do any mistakes if we get a question like this way. Now the question is, let ABC belongs to R and A is not equal to 0. Full stop. If alpha is a root of a square x square plus bx plus c is equal to 0, beta is a root of a square x square minus bx minus c is equal to 0, and we have been given these alpha and beta are both positive, then equation a square x square plus 2bx plus 2c is equal to 0 has root gamma, that always satisfies a part gamma is equal to beta, b part gamma is equal to alpha, c part gamma is equal to alpha plus beta by 2, and the fourth part is gamma lies between alpha and beta. Now look upon this question. We have been given a not equal to 0. It means this is a quadratic if a not equal to 0. Then we have been given out a, b, c belongs to real numbers. This all variables, these all constants a, b and c are real. Then now we use the conditions given by one. First thing will be given alpha is a root of this one. So we start a solution from here. The solution of this question will be, since alpha is a root of a square x square plus bx plus c is equal to 0, we can say a square alpha square plus b alpha plus c is equal to 0. If alpha is the root of this equation, then alpha must satisfy this equation. Then another thing, we have been given out beta. Condition number 2 which has been given out, beta is a root of, it is a square x square minus bx minus c is equal to 0. Now a square x square, it is a square beta square minus b into beta minus c is equal to 0. So we can conclude from here beta must satisfy this equation. Now these are the two conditions, we get it from these two lines. Now we have been given out third. Third one, if this equation has a root alpha. See, this root has a root gamma which satisfies this one. So it is, so I take function like we have been doing in intermediate value theorem. Let fx is equal to a square x square plus 2bx plus 2c. See, looking upon the four options, we have to see what is the relation between gamma, alpha and beta. We find out f alpha. F alpha is a square alpha square plus 2b alpha plus 2c. Now, alpha we have in this equation number 1. See, we underline it here and we can say, looking upon this one, we can say b alpha plus c is equal to minus a square alpha square. From here, this is the given condition. We find out the value of b alpha plus c from here, that is equal to minus a square alpha square, and put this over here. We got f alpha is equal to, this is a square alpha square plus 2b alpha, it is plus 2 b alpha plus c. In place of b alpha plus c, I substitute, this is minus a square alpha square. I got it minus a square alpha square. This is f alpha. So f alpha I got as negative 1. Now I find out the value of similarly f beta. F beta, I am going to substitute over here. It is f beta. This is f beta is equal to a square beta square plus 2b beta plus 2c. Again, the given relation, the given condition in beta is this is one. From here we can conclude one thing, a square beta square is equal to b beta plus c. This is the thing. Now I substitute this relation over here. I will say f beta is equal to, this is a square beta square plus 2. Instead of b beta plus c, I will substitute 2 a square beta square. I got it 3 a square beta square. This is f beta. From here we found, since this equation has been given out, we find out in this function f alpha is negative. F alpha is negative and f beta is positive. See, if we have solved it, we draw a conclusion from here, f alpha is negative, f beta is positive. So what does it mean? It means if we draw a graph over here, f alpha is on the left hand side, alpha will be greater than 0, it will be over here, it will be over here. So f alpha is negative, f alpha is negative somewhere here, I take it. F beta is positive, somewhere positive. So if we join it, we find out this is the thing. It means this is the point what gamma. This is the root gamma. It has at least one, or it is a quadratic function. So we will say what? We will say it has one real root, and that gamma lies between alpha and beta. So the right option is, it is D option. Again, little difficult question, but you again try to understand it. I am going to start from the beginning. See, we have been given out that alpha is a root of ax square plus bx plus c is equal to 0, and beta is a root of this equation. So I'll start it from here. Alpha is a root of this equation. I got it this equation. A square alpha square plus b alpha plus c. Now f beta. Beta is the root of this equation. I substitute beta over here. I got this equation. Now this equation has been given out, and we have been given it has a root gamma. It has one root gamma, and we have to calculate the relation between alpha, beta and gamma. That means we try to calculate the values of alpha. F alpha is a square alpha plus 2b alpha plus 2c. F alpha is this one. From here, using this given condition, we find out a square alpha square b alpha plus c is minus a square alpha square. Substituting it over here, f alpha की वहाँ पर वैल्यू आ गई है, it comes out to be negative. अब हमने क्या किया, f बीटा की वैल्यू निकाली. f beta is a square beta square plus 2b beta plus 2c, और गिवन कंडीशन को यूज किया. गिवन कंडीशन इज b beta plus c is a square beta square. Substituting over here, we find out f beta is positive and f alpha is negative. So we got a graph over here. It means f alpha is negative, f beta is positive. I'll again draw a graph. Even without drawing a graph also we can conclude intermediate value theorem. It is, this is alpha, this is beta, this is negative, this is positive. So it comes out to be like this way. We can conclude one thing, this is f alpha is negative, this is gamma. This is one root, that root has been given as gamma. So we'll say the root gamma lies between alpha and beta. Now the next problem is, if a plus b plus c is equal to 0, then quadratic equation 3ax square plus 2bx plus c is equal to 0 has a option is given as at least one root in 0, 1. B option is one root in 2, 3, and other in -2, -1. And other in -2, -1. The C given option is imaginary roots, and the D option is it is none of these. See, we'll do this question by using the concept of a Rolle's theorem. See, what is a Rolle's theorem? It is a part of topic of application of derivatives in class +2. See, Rolle's theorem, first of all, you have to understand what is Rolle's theorem. The Rolle's theorem states if a function fx is such that a part, it is fx is continuous in closed interval AB. Second thing, fx is differentiable. fx is differentiable in open interval AB. And third condition is fa is equal to fb. Then there must exist at least one value c in AB such that f dash c is equal to 0. See, try to understand the Rolle's theorem, especially with the graph also, because we are doing just intermediate value theorem. The great mathematician Rolle's, he states if a function is continuous in the closed interval, he says a function is continuous in the closed interval AB and it is differentiable. Differentiable means no pointed graph. So this is x-axis, this is y-axis. We suppose it is a supposed curve like this way. I take this point as A, this is A, and I take this point as a B. I have taken at this much distance same as the conditions of the Rolle's theorem is Fa should be equal to Fb. I will say from here looking upon the graph we can say Fa is equal to Fb. So Rolle's theorem states if Fa is equal to Fb and function is continuous, Fx is continuous without any break and it is differentiable. It is differentiable. It means at every point we can draw a tangent, then there must exist at least one value C. Then कम से कम एक पॉइंट पर टेंजेंट पैरेलल टू एक्स एक्सिस होगा. टेंजेंट पैरेलल टू एक्स एक्सिस क्या होगा? दिस इज द पॉइंट एक्स इज इक्वल टू सी. This is we can say C comma 0. This is the graphical representation of a Rolle's theorem. Rolle states once again understand in a short FA FB के equal है और ये polynomial है. Polynomial it is continuous in the whole interval from A to B and it is non-differentiable. It is no pointed graph between A and B. Then it must have at least कम से कम एक पॉइंट पर वी कैन ड्रॉ टेंजेंट पैरेलल टू एक्स एक्सिस. टेंजेंट पैरेलल टू एक्स एक्सिस का क्या मतलब है? एट दैट पॉइंट एफ डैश सी इज इक्वल टू 0. दिस इज एट लीस्ट वन पॉइंट means we can say another thing also. It is if this is a curve like this way, this is A, suppose this is A comma 0, this is point, it is B. So Fa is equal to Fb. I will say Fa is equal to Fb, and we're taking this curve into account. We'll say Fa from A to B. The function is continuous, and it is non-breakable, and it is differentiable. मतलब we can draw a tangent at every point. Then there must exist at least one value. At least one value. कम से कम एक पॉइंट पर टेंजेंट ड्रॉ कर सकते हैं. वन पॉइंट वी कैन ड्रॉ इट अनदर पॉइंट्स. सो इन दिस केस वी सी इट at there are 2 points in which we can draw a tangent and tangent parallel to x-axis. Now we are doing this problem using this concept of a Rolle's theorem. Now considering this fact, we have been given quadratic equation 3ax square plus 2bx plus c0. It means I take this as f dash x. I take this as f dash x. It is equal to be 0 means 3ax square plus 2bx plus c. Now integrate it. Why integrate it? To get our function fx is equal to 3a x cube by 3 plus 2b x square by 2 plus cx. So we got our fx as ax cube plus bx square plus cx. This is a function. So now using Rolle's theorem, we are doing this problem. It is let our function is what? It is ax cube plus bx plus cx, bx square plus cx. Now we have say we have been given a plus b plus c0 means f1 a plus b plus c, and it has been given as 0. We find out what is f0. F0 is substituted, we'll get it 0. So we can say here f0 is equal to f1. Since it is a polynomial, so must be continuous. Must be continuous in 0 comma 1 and must be derivable in open interval from 0 to 1. F0 is equal to F1 means Rolle's theorem satisfied. Means Rolle's theorem satisfies. So we get the rightful value. We have to find out the interval. It means it has at least one root in 0 to 1. So this is a thing we use a Rolle's theorem. Rolle's theorem states a function is continuous, differentiable, and f0 is equal to f1, then it must have at least one value c in AB.